Okay, so quick recap. Multiplicity means that a factor happens more than once. In this case, the x-intercept's at 1, it has a root at 1, and we would say that that root has a multiplicity of 3. And now looking at these two graphs, the first graph, x minus 1 squared, we would say that root has a multiplicity of 2. Second graph, this x minus 1 cubed, that root has a multiplicity of 3. So off to the side, we're going to say that if you have an even multiplicity, like we did in this example with a multiplicity of 2, wherever that x-intercept, the graph is going to bounce at that x-intercept. And if you have an odd multiplicity, two things could happen. An odd multiplicity, the graph will always go through the x-intercept, and it'll go through the axes. If it's a 1, in other words, these are the examples that we've seen so far where we've just had a factor appear once, then your graph goes straight through the x-intercept and continues on. If the multiplicity is odd, but a bigger number like 3, 5, or 7, and so on, it is going to bend. It's going to bend at the x-intercept. And we can see this with this one here where the graph had an x cubed. It has that same intercept, but the graph bends at that point. And we've seen that bend in all of our x cubed graphs when we did our transformations. So we're going to now look at if we can factor things and get our x-intercepts and know our end behavior plus the multiplicity, we'll be able to graph things even clearer. So in example 3 here, okay, first thing we need to do, find x-intercepts. I'll put factoring in brackets. And y-intercept. Second, we're going to use the end behavior to help us graph it. And now we're also going to think about and use the multiplicity. So now we have 3 things to help us sketch these graphs. The nice thing in A and B here is they're both already factored. So if I want to find my x-intercepts, I can plug in 0 for y, and I get x equals -1 and x equals 2. You might already, at this point, make your note about multiplicity. This one has a multiplicity of 4. That root has a multiplicity of 4. This root has a multiplicity of 1 because it only appears once. You could find your y-intercept, plug in 0 for x, we have to do a little bit more math this time because it's already factored, but 1 to the power 4 is 1 times a -2. Our y-intercept will be -2. We also have to do a little bit of thinking about our end behavior. What kind of graph is this? What's going to be the highest power when it's multiplied all out? Well, you don't have to multiply it all out completely. Can you see that when you have x plus 1 to the 4, you would have an x to the 4 in that part? And you have another x here, so you're leading your highest power is going to be an x to the 5. And its leading coefficient is going to be positive. And so this graph's end behavior is going to act like a line. So now that we have our x-intercepts, we know the end behavior, and we know the multiplicity, we can graph. So on my graph, I want x-intercepts of -1 and 2. There's -1. There's 2. On my graph, I want a y-intercept of -2. I know that it acts like a line, so that I know my graph starts down here. And because it has a multiplicity of 4 at -1, it's going to bounce off that x-intercept. And at +2, it's going to go straight through. So here we have our sketch of our graph of A. So the multiplicity tells us that it bends at -1 and goes straight through at 2. Our end behavior tells us that we're going to start in the bottom left and end in the top right. And we're going to go through all of our x-intercepts and our y-intercepts. So let's look at B. Again, B is already factored. And since it's already factored, we can find our x-intercepts. We're going to have an x-intercept at -1 and an x-intercept at 3. This x-intercept has a multiplicity of 3. This x-intercept has a multiplicity of 1. If you expanded this, can you see that your leading coefficient of your highest degree, you're going to get a -x⁴ graph? Because I have, basically what you're doing is you're looking at, here I have an x, here I have an x. This x is once, this x is 3 times because it's getting cubed. That'll give me x⁴. Plus I also have a negative out in front, which will give me a -x⁴. So when I'm thinking about the end behavior here, I know that it acts like a parabola that's going down. These were my x-intercepts. If I want to find my y-intercept, I would plug in 0 for x, so -0 plus 1 cubed, 0 minus 3. Which will give me -1 cubed is 1. -1 times -3 is +3. So going to my graph, I'm going to have an x-intercept at -1, an x-intercept at 3, a y-intercept at 3. My graph is going to bend at -1, go straight through at 3. I'm starting down here. I need to bend, go through that point, straight through that one. And when you show your bend, your graph almost comes completely flat at the bend. Questions 9, 10, 11, and 12.